Hey everyone, here's our next video. This one's starting off our new unit on polynomials. As you can see, we're at the top of page 367, so pause, get yourself to that page. And the first section here is called adding and subtracting polynomials. And we're going to do that in class together, but to start here, we got to talk about what in the world is a polynomial. We're going to write down a few things here. Let's start with the definition. So a nice easy definition is an algebraic expression made up of one or more terms. And if you remember terms, we've heard that word before. It's anything separated with a plus or minus. Now, what does that mean? What are some key facts and characteristics? A couple key things. Any exponents you see, they must be positive whole numbers. We'll see some examples here. And we're not going to have any variables in the denominator. So in order for something to be a polynomial, it's got to meet those two things. Okay. So what are some examples of polynomials? Let's write down a few. One example would be 3x squared plus 7x minus 1. Notice it's got multiple terms, 3x squared, 7x, 1, negative 1. Any exponents, so x squared, x to the first, it doesn't say an exponent there, but it's there. They're positive, and they're whole numbers. They're not decimals, they're not negative. And then there's no variables in the denominator. Okay, if you see a fraction, there can't be a variable in the bottom. And this one doesn't have it. Another example would be like 4x to the 10th minus 8x. A third example could be 7, just on its own, the number 7. Because it says it could be made up of one or more terms. What about some things that are not examples? If we had 4x to the negative 8th plus 7, that would be not a polynomial because we can't have a negative exponent. Or what if we had 6x to the 2.4 minus 3x plus 1? That's not a polynomial either because we can't have 2.4. You can have a decimal. Okay, they gotta be positive. They gotta be whole numbers. No variables in the denominator. I couldn't have if we had like 4 over x plus 3. That's not one either. Those are non-examples. Those are not polynomials. We have 3 other important definitions. You can see they're already there for you. Standard form. Oh, it's another standard form. We keep talking about standard form, right? Standard form is when we write about writing a polynomial in decreasing order of exponents. Leading coefficient is the number in front of the highest degree, and that comes first if we write it in standard form. And then the degree is the largest exponent variable the variable has in a polynomial. Okay, so moving down the page here, we have these 2 ways of classifying a polynomial, like kind of giving them characteristics. It's almost like the first name and the last name of the polynomial. And so one of the ways we classify is with the degree. We call it the degree. And right above you see it's the largest exponent the variable has in a polynomial with one variable. So we have several words that we use for the degree. And so let's fill these in now. So take a second to write these down. When the degree is 0, we call it a constant. And that's maybe even a word you've heard before. We have constants and we have variables. If the degree is 0, that means there's no variable, and so we call it a constant. Linear is when the degree is 1, like a straight line, linear, and that's just x to the first. Quadratic is if it's x squared, x to the second. Cubic is to the third. And then fourth and fifth are kind of more rare ones, but we'll give you the names anyway. Quartic, like quarters, 4 quarters in a dollar. And quintic, like quintuplets. 5 degree is 5. Okay. I think the most important are those first 4. We can maybe even put stars next to them or something that looks like a star. So we're going to start to get to know those words really well, especially those first 4. We can also classify a polynomial based on its number of terms. And we have some words for those as well. So you can see those there. If it's a 1-term polynomial, we call it a monomial. 2 terms, binomial, like bicycle, 2 wheels, binomial. 3 terms, trinomial, tricycle. Anything bigger than that, we just say like, oh, that's a 4-term polynomial or a 5-term polynomial. So for this one, we're really keying in on those first 3 are the most important. Monomial, binomial, trinomial. So let's flip to the next page and just do some practice problems here. So we're going to take a look at this chart on page 368 and kind of work through filling these in. So the polynomials are on that first column on the left. So here we go. First one is just 5. Notice there's no variable. If there's no variable, we say the degree is 0, and the word we had for that was constant. Number of terms, there's only 1 term there, so we call that monomial. And the leading coefficient, this is the easiest one, when it's just one thing, it's just the 5. It's the number. The coefficient is the number in front of the first term. There's only 1 term, so it's that. Okay, then we have x plus 4. I'm going to write a couple of invisible ones. Remember, it would be 1x plus 4, and the exponent on x is 1. So now the biggest exponent we see is that 1, and that means our degree is linear. This one has 2 terms, which makes this a binomial. And the leading coefficient is the number in front of the biggest degree term, which is 1. We're going to skip the ones where we have to create the polynomial until the very end. Let's look at this one, 4x squared. Okay, 4x squared. I see the biggest exponent is 2. The only exponent is 2. And so when that's the case, that means it is degree 2, which we call quadratic. It is also only 1 term, so that means it is a monomial. And the leading coefficient is the only number in front, and that's 4. Next example here, 4x cubed minus 2x squared plus x. Let's do this. Let's underline all the terms. So there's 4x cubed minus 2x squared plus x. 3 terms, that has a word. That's called a trinomial. That's how many terms there are. I'm also going to put little like arrows pointing to the exponents. I've got an exponent of 3, exponent of 2, exponent of 1. The biggest one is 3. And the word for that is cubic. I also am going to circle that first coefficient, the one in front of the biggest exponent. So my leading coefficient there is also 4. Okay, when we look at the next problem down here, 2x to the 4th plus 5x squared, I have 2 terms. That makes it a binomial. The biggest exponent is 4. If we looked on the previous page, we would see that means this is quartic. 4 quarters, quartic. The leading coefficient, what do you think it is? You said 2, you are correct. Finally, the last problem at the bottom, Okay, let's see. What do we got? I have 1, 2, 3, 4 terms. So that just makes it a 4-term polynomial. And the biggest exponent is 5. If you look at the previous page, what did we call 5? It's quintic, or quintic. Sorry, quintic. I used to think it was quintic, but no, quintic. And finally, the leading coefficient. Okay, it is that number in front of the first term there. Ooh, there's an invisible 1, -1. Okay. It asks us to create some examples here. So in the problem where it says we're going to make a linear monomial with a leading coefficient of -7. Linear means my biggest exponent is going to be 1. Monomial means there's going to be one term, and it has to have a leading coefficient of -7. So I know I have to write -7 and x, and since it's only one term, to make it linear, I need it to be x to the first. So it'll be -7 x to the first. Would be that. Quadratic means it's degree 2. Trinomial means we have 3 terms, and the leading coefficient has to be 5. So for it to be quadratic, I need my first exponent, my biggest exponent, to be 2. So it's going to be 5x squared. Now I need 2 more terms, so I'm going to just do like a linear term and a constant term. I can do any numbers I want. Minus 37x plus 11. You could do any numbers there, but it has to be x and 11 and a constant. I couldn't do x to the third because then that wouldn't be quadratic anymore. It would be cubic. So that's our example there. To make a cubic, I would need degree 3. And binomial means 2 terms and has to have a leading coefficient of 3. Why don't you pause it and try to write your own? Okay, here's the one I'm coming up with. 3 for my leading coefficient, and to make it cubic, it has to be x cubed, x to the third. And then binomial means I can do one more term. So I'm going to do plus 6. You could also have plus 6x squared. You could have plus 6x. You could have plus 30x. It doesn't matter as long as it's a term that is lower than cubic. Can't have an exponent bigger than 3. Okay, we're going to practice this a bunch coming up, so hopefully this was a good introduction. Thanks for watching.